AI products break testers' assumptions. They don't behave deterministically. They don't always give the same output. And sometimes there is no single correct answer. So how do you build a test strategy around something that isn't strictly pass or fail? Well, that's what we're unpacking today. So there's been a lot of discussion recently around AI testing strategies. Some good points, some surface level thinking. But most conversations miss something critical. You don't test AI the way you test traditional software. You design strategy around behaviour, risk and evaluation, not verification. And if you don't adapt your strategy, you'll apply the wrong quality model to the wrong product. I put together a handy checklist to allow you to build your own AI test strategy plan. So let me know in the comments if you'd like that sending and I'll give you the link to download it. It's really an invaluable crib sheet. So why AI products are different? Let's start with the fundamentals. So as we all know, traditional software is deterministic. You input A, you expect B. If you get C, it's a defect. AI doesn't work like that. AI systems are probabilistic. The same prompts can generate slightly different outputs. So two correct answers might look different, and sometimes the best answers depend on context. So the question changes from, is this correct, to, is this acceptable? Is this safe? Is this within tolerance? That's a completely different test mindset. So what are the differences? There are actually three structural shifts when testing AI products. First, non-deterministic output. Second, subjective evaluation. And third, expanded risk surface. And that third one is critical. AI risk isn't just functional bugs. It includes bias, hallucination, unsafe responses, misused data, data leakage, ethical implications. Your test strategy must account for those. So what is it that most teams are getting wrong? Well, what I see a lot right now is this. Teams bolt traditional test cases onto AI features, then try to create expected output files, run regression comparisons, and treat it like every other microservice. So that works for infrastructure, but it doesn't work for intelligence. You cannot rely purely on pass-fail automation. You need evaluation models. So what are the core goals of an AI test strategy? And as I said, I can give you those in a handy PDF document that you can download. As I say, just check the links or add a comment just to request it. So let's define what a test strategy around AI should actually aim to do. So number one, behaviour evaluation, not binary verification. You measure quality and dimensions like relevance, accuracy, tone, safety, consistency. And number two, guardrail validation. You intentionally test misuse cases, prompt injection, edge case abuse, boundary probing. Number three, statistical tolerance modelling. You don't check it's always right, you check if it's right enough within the thresholds. Number four, production monitoring. AI products degrade, they drift, they respond differently over time. Testing doesn't stop at release, it moves into observability. So where a test strategy must go deeper? Well, one thing I think most discussions miss is an execution design. It's easier to say test AI differently, it's harder to operationalize that. So here's a practical framework I use conceptually. This is what I call the 5-pillar AI test strategy framework. So where are they? So pillar one is define evaluation dimensions. What does quality mean for this AI feature? Accuracy, safety, bias neutrality, response time, business relevance. You cannot test what you haven't defined. So pillar two, build guardrail suites. Design prompts that intentionally try to break it. Boundary testing for behaviour, not just for data input. Pillar three, apply statistical scoring. Instead of pass-fail, use scoring bands, for example, 80% relevance threshold, 95% safety compliance threshold. Pillar 4. Integrate with CI/CD. AI testing must plug into pipelines, evaluation scripts, automated prompt libraries, regression drift detection. Pillar 5. Monitor in production. So track outputs and quality metrics. Use feedback loops and anomaly detection. That is a real strategy. So here's a practical example. So let's take a chatbot product. You don't just test, does it return exactly this sentence? You test, is the answer relevant? Is it factually grounded? Does it avoid unsafe advice? is tone appropriate. You score those dimensions. Now take a recommendation engine. You don't just test, is this the correct recommendation? You test click-through rates, diversity, bias patterns, drift over time, different product, different evolution logic, diversity, bias patterns, drift over time, different product, different evaluation logic, same principle, behaviour over binary. If you take one thing away, take that sentence. So the human role and how this is still important. Well, AI does not remove the need for testers, and we've covered that on numerous videos on this channel, so check them out. It increases the need for quality judgment. Someone must define what acceptable risk looks like, what tolerance means, what thresholds matter, and when to intervene. AI accelerates execution. Humans still own the consequences, and that's the difference. So, what are the skills that the QA professionals need nowadays? If you want to stay relevant in AI product testing, you need risk modeling capability, understanding of bias and fairness, basic statistical literacy, prompt evaluation frameworks, observability awareness, CI/CD integration thinking. So not just automation scripts, this is where the market is shifting. And again, I've just made a video on where the market is at the moment in time for job roles. So again, check that video out, and that's a really useful PDF in there as well to draw down on where the testing market is going at the moment. So what's the strategic shift? The biggest shift in AI testing strategy is this. We're moving away from finding defects to managing uncertainty. That's a much more senior discipline, and the teams who understand that will perform. So if you're building or testing AI features right now, I'd be interested to know what's been the hardest thing: evaluation, guardrail, monitoring, convincing stakeholders. Comment below. I'm always really interested to hear what the community has to say. And as I said before, if you'd like a structured AI testing strategy checklist, let me know and I'll send you the link so you can download the PDF. Inside STLC is about signal, not hype, and AI quality is only going to become more important from here. So I'll see you in the next one.